Your support team just got crushed. A customer's refund request sat in the queue for 6 hours because the agent checking the order system had to wait for a response, then manually draft an email, then escalate. Meanwhile, your data pipeline broke at 2 a.m. because a transformation script didn't handle a schema change. These aren't edge cases, they're the daily reality of systems that don't think. AI agents fix this. An agent is an autonomous system that perceives what's happening, reasons about it using language models, and takes real actions, calling APIs, running queries, making decisions, to reach a goal. After this video, you'll understand how to design an agentic loop that doesn't spin forever, how to ground reasoning in real tools and data, how to manage memory so your agent doesn't forget context or waste tokens, and how to build failure handling that stops silent catastrophes. Every agent follows the same cycle: observe the current state, reason about what to do next, execute an action, usually calling a tool, then observe the result and loop. A customer support agent reads a ticket, checks the database for order status, sees the result, decides whether to issue a refund or escalate, and either acts or loops back for more information. This sounds simple, but the devil is in the details. First, you need to decide when to loop and when to stop. Set a maximum step count, usually 5 to 10, to prevent infinite loops. If the agent hasn't solved the problem by then, escalate to a human. Second, you need clear tool definitions. Tell the agent exactly what each tool does, what inputs it needs, and what output it returns. Third, you need to observe failures. When a tool call fails, a database timeout, an invalid parameter, an API rate limit, the agent needs to know. Pass the error message back into the loop so the agent can retry with a different approach or call a fallback tool. Now let's talk about tools themselves. A tool is any external system your agent can interact with: a database query function, an API call, a calculator, a file reader, even a human confirmation step. Tools ground abstract reasoning in concrete, verifiable facts. Here's the key principle: design your tools to be narrow and composable. One tool should do one thing well. Instead of a single massive tool that tries to handle every query type, create separate tools for read operations, write operations, and schema inspection. This makes it easier for the agent to reason about what's available. Also, validate tool inputs before the agent calls them. If a tool expects a product ID, check that the agent is actually passing a valid ID, not a hallucinated number. This prevents wasted API calls and keeps the agent focused on real problems. Tool outputs matter just as much as inputs. Return structured data, JSON, not free text. Instead of a tool returning the order was placed on Monday and shipped last Friday, return structured data. Structured data is easier for the agent to reason about and easier for you to validate. Now let's tackle memory and context windows. Language models have a token limit. Claude has 200k tokens, GPT-4 has 128k, and that's everything combined: your system prompt, the agent's observations so far, the current task, and the tool results. A 5-hour conversation can consume 50,000 tokens before the agent even starts reasoning. This is where strategic memory management comes in. For short-lived agents, a single customer support ticket, one data pipeline run, keep the full conversation in context. You have room. For long-running agents, you need to summarize. Here's a real production pattern: instead of storing full chat logs, create a structured summary. After every 10 steps, extract the key facts the agent needs and compress the old conversation into one JSON object. Then delete the old messages. A typical compression saves 70 to 80% of tokens while keeping all the decision-critical information. Another pattern: Retrieval-Augmented Generation, or RAG. Don't put the entire knowledge base in the context window. Instead, embed it in a vector database. When the agent needs information, it queries the database, gets back the top 3 or 4 relevant documents, and includes only those in context. One more: sliding window memory. For agents operating over days or weeks, only keep the last n observations in context, say, the last 5 tool calls and their results. Everything older gets archived. The agent can ask for archived history if needed, but it's not in the main context by default. All of these techniques trade off completeness for efficiency. You lose some context. But if that loss prevents token waste and keeps your agent fast and cheap, it's a win. Now let's talk about the failure case that trips up most first-time builders: the infinite loop. An agent gets stuck calling the same tool over and over with slight variations, never making progress, burning tokens and time. Why does this happen? Usually because the agent doesn't understand that its action failed, or because it has no fallback strategy. You need 3 layers of defense. First, explicit error handling in the loop. Catch tool errors, timeouts, invalid inputs, permission denied, and pass them back to the agent with context. Second, backtracking logic. If an agent tries the same action 3 times in a row and keeps failing, stop and escalate. Don't let it retry infinitely. Third, fallback tools. If the primary tool fails, have a secondary option. Here's a concrete example from production. A data pipeline agent needs to validate data quality. It calls a SQL query to count rows by status. The query times out. Without error handling, the agent hallucinated that it got results and kept going, corrupting the pipeline. With error handling, it caught the timeout, switched to a simpler query, and used that. One hard truth: AI agents are not a solved problem. They work brilliantly for well-defined, multi-step tasks with clear success criteria. They struggle with ambiguous goals, high-stakes decisions, and domains where hallucinations are catastrophic. Don't use agents for medical diagnosis, financial advice, or critical infrastructure without human approval loops. Do use them for internal data tasks, customer support triage, content generation, and automation of repetitive workflows. Know the boundary. Also, agents are expensive in development time and tokens. A single agent run might make 10 tool calls and consume 50,000 tokens. If you're running that hourly across a large system, costs add up fast. Sometimes a simple rule-based system, or a traditional microservice, is more practical. Use agents where the problem is complex enough to justify the overhead. Let's wrap up with a real design example: building a customer support agent. Step 1. Define the goal. Resolve customer tickets in under 5 minutes, or escalate to a human. Clear success criteria. Step 2. List the tools you need. Step 3. Write the system prompt. You are a support agent. Your job is to understand the customer's issue, check the order and refund policy, and either resolve it or escalate. Always be honest about limitations. If you're unsure, ask for human help. Step 4. Implement the loop. Initialize with the ticket text. Repeat. Call the LLM with the current state and available tools. Parse the tool call. Execute the tool. Observe the result. Add it to context. Loop until the agent decides to stop or max steps is reached. Step 5. Test and monitor. Run it on 100 tickets and compare the agent's resolutions to human resolutions. Track loop count, token usage, and failure rate. Adjust tool definitions, memory management, and fallback logic based on what you learn. Step 6. Deploy with guardrails. Set a maximum token spend per ticket. Log every decision. Route high-stakes resolutions through human review. Measure customer satisfaction and iterate. That's the full journey from concept to production. An AI agent isn't magic, it's a loop, some tools, memory management, and failure handling. Design each piece carefully, and you'll build systems that scale and adapt in ways that static code can't. Thanks for watching. If you want more practical AI system design tutorials, subscribe and hit the bell.